is section 4.6, and this is a video. I mainly did it to introduce you to the quota rule, so they ask which apportionment, now that we've learned about all these apportionments, which is the best? And here are a few things to think about to like try to judge which ones are best or which ones are not best. Is the first one is the quota rule. If apportionment is a good method, it should meet the quota rule, and that is that every state should receive either their lower quota or their upper quota, right? And that's going back to if we were thinking about if we wanted to give someone $3.33 and we didn't have any change, the best option would be to give them $3 or we'd give them $4. So those are the two best options. So when we break the quota rule, or if we break the lower quota rule, that means we gave them lower than their lower quota. If we break the upper quota rule, it means we give them more than their higher quota. So that's the quota rule. Then the apportionment paradoxes summed up. The Alabama paradox is it occurs when a state gets fewer seats simply because the total number of seats increased. Let me repeat that. So it occurs when a state gets fewer seats simply because the total number of seats increased. So that doesn't make sense. If we add seats to Congress, I shouldn't get less seats. There should be more for everybody, or at least that I had before, right? And then the population paradox occurs when a state gets fewer seats simply because of the population increased. So like if nothing changed and all that happened is my state increased in population since last year, I would expect to at least get the same number of seats in Congress, if not more, right? But if I get fewer seats, then something bad's happening. Okay. Then there's a new states paradox, and that occurs when a state gets fewer seats when a new state is introduced. So they didn't do anything different. Their population stayed the same, and we actually maybe added the right amount of seats in Congress to add that new state. But for whatever reason, when recalculations are done, all of a sudden, one of the older states gets fewer seats just because the new one was added. And so that shouldn't happen. So then there's Belinsky and Young's impossibility theorem, and it states there's no perfect apportionment method. They either violate the quota rule or they can produce paradoxes, one or the other. It always happens, unfortunately. So let's just double check your understanding of the paradoxes and the quota rule. Let's answer some possible test questions. Identify the statement. It is mathematically impossible for an apportionment method to be flawless. Any apportionment method that does not violate the quota rule must produce paradoxes. And any apportionment method that does not produce paradoxes must violate the quota rule. So what is that? That's Belinsky and Young's impossibility theorem. Under a certain apportionment method, so this is number 2, a state receives an apportionment of 42 seats when the total number of seats of legislature what is 234. But only 41 seats when the total number of seats in legislature is 235. So this is called the Alabama paradox. We read back up above, the Alabama paradox occurs when a state gets fewer seats simply because the total number of seats increased. So the thing here is the total number of seats of legislature went from 234 to 235, which means the total seats in legislature increased, but this particular state actually went down in its number of seats. So that's called the Alabama paradox. In the new states paradox, the new state does not get a fair number of seats. That's not true, because in the new states, when they add a new state, they usually figure out how many seats they should be appointed, and then they make sure to add that many of seats if there's a new state added. So, well, that's what they used to do, at least with Oklahoma in the past. So that one wouldn't be right. A is not right. The new state gets more than its fair share of seats. No, we said we'd add exactly for that state. And the amount for that state. The new state gets a seat at the expense of an old state. No. Because we added the same amount of, exactly the amount of seats that state should get. One old state gets a seat at the expense of another old state. Yeah, that's what happens. And if we read it back up there, in the new state paradox, when they add a new state, when a state gets fewer seats as a result of the new state being added. So there you go. It's somebody got a fewer seat, and it's an old state getting the seat compared to another old state. Okay, because you can't change the number of seats that a new state got, because they just joined. They don't need. Okay, anyways, one state must give up a seat to another, even though it grew at a faster rate than the state receiving the additional seat. This situation is the population paradox. And that one states that it occurs, a paradox occurs, which a paradox is something bad that you don't want to happen. Anyways, a paradox occurs when a state gets fewer seats simply because their population increased. So that's what's happening here. And their population increased more faster than another place, but they still lost a seat. Okay, at the time of the 2000 census, California's standard quota was 52.45. Under Jefferson's method, California would get an apportionment of 55 seats. This is a lower quota violation and upper quota violation, example of Alabama's paradox, or example of new states paradox. Well, they're getting higher. Their upper quota would have been 53. We can't give them 52.45 exactly. Let's give them 53 possibly, or 52, right? But they're giving them 55. You're like, well, no, you're supposed to get 52. Why are we giving you 55? That's above the upper quota. So this is an upper quota violation, B. Okay. At the time of the 2000 census, California's standard quota was 52.445. Under Adams' method, California would get apportioned to 50 seats. So this is the example of a lower quota violation, because this is smaller than the lower quota. They should have, at minimum, they should have gotten 52 seats, and at max, they should have gotten 53, right? This is the min. Well, they went below that lower quota, so that's what is a lower quota violation. An apportionment method is used to A, give an equal number of different items to all players. Well, we don't give an equal number to everyone, so no, that's not right. Okay, give different amounts of the same items based on population. That sounds correct. But we'll see, read them all and see. Determine how much power a player has over. That sounds like from last chapter. give different amounts of different items. No, we're not giving different items. It's always the same item. So it's B. Okay, and then what is the current method of apportionment for the US House of Representatives? So this is an interesting question. Like, so how do they really hand out the seats in Congress to this day? And the answer is they're using Huntington Hill's method. Isn't that neat? Until they find a better way. I think it's a Huntington Hill's method. And there you go. I hope you found this valuable. Have a great day. Bye.